Welcome to tutorial number 1. In today's tutorial, we're going to be going over the different learning systems that are employed in order to train an ML model. In today's video, we're going to be going over that, but let's talk about the book that we'll be using for this particular course. And so the book that we'll be using are Hands-on Machine Learning with Scikit-learn and TensorFlow. And so many of the examples that we're going to be getting are going to be derived from this particular book. And so in every tutorial, I'm going to minimize the information that's going to be covered over several pages in the book, but I'm going to minimize that down to a PDF file, I'll convert the Microsoft Word document into a PDF file, and it'll be essentially about 2 or 3 pages long. But you can see here that this PDF file that I created is covering pages 7 all the way to 14. And so it's covering roughly around 7 to 8 pages, but I'm just trying to minimize this all down into roughly about 2 pages in the PDF file in order for you to really understand this information and understand the major points that are brought up in these particular pages. And so for today's lesson, we're going to be covering supervised, unsupervised, semi-supervised, and reinforcement learning. And so these are the 4 different types of learning algorithms, learning systems that we're going to be using. When it comes to an ML model, obviously, as you might know, is trained with data. That's probably a word that you heard before, trained. It's trained with a particular amount of data. Normally, it's a large amount of data. Now, the data itself is in a particular format, and that's where supervised and unsupervised comes into play. The training set that you feed into the algorithm can include labels, or it does not have to include labels. In both of these examples, it has to include certain characteristics. And so, for example, let's take a look at our first example. You see here that we have emails. In these emails, you see that certain emails are spam emails, other emails are non-spam emails, right? And so you see the ones with the red warning symbol, those are spam emails, and the ones with the green check mark, those are non-spam emails. And so this is the training set that we're giving to the ML model. Now, what the ML model is going to do, it's going to train itself using this information. And then the user, once it's done training, is going to ask the ML model, this is an email that I have. Is it spam or non-spam? Right? And so the ML model is going to use the instances that have been provided to it, the characteristics of those instances, as well as the labels that are associated, either spam or non-spam, with those particular emails, and it'll determine whether or not that new instance that a user is providing is a spam or a non-spam email. And so that's what you have there with regards to your training set there. All right. And so another example could be, we went over classification. Another one would be, for example, the price of a car. And by the way, even spam filters, when you think about these are things that have been around since like the 1990s. So these are not necessarily even new developments. I mean, this whole idea has been a fairly old development, but it is still an ML application there in terms of training, how to train the ML model. How about the price of a car? We could, for instance, give several cars to the ML model, and we can give characteristics of those cars. Those characteristics, by the way, of those cars are what we call predictors. And so you see that term right there, predictors. And so those predictors could be for a car, for instance, in determining the price of a car, could be the mileage of the car, the brand of the car, the age, how old the car is, right? Those are all characteristics that you consider when you're determining what the price of a car is. So we give those particular predictors to the ML model. We also give labels because, again, this is supervised learning. The training set you feed to the algorithm includes the desired solutions that are called labels. Those labels in this case would be the price of the car. So we give characteristics of the car, but we also give the price of a car that is associated with those characteristics. And we use that as our training set for the model. And now, once it finishes training, we'll ask the user, I have a car that has certain characteristics. For example, we could give a car, for instance, that has a Toyota brand. It's 10 years old and it's run 200,000 kilometers, let's say. And we're going to be asking the ML model, based on everything you have, based on the labels that are associated, the prices that are associated with the cars that you already have, can you predict a price for the car? And so that's essentially what supervised learning is. We're giving a label and we're giving certain characteristics called predictors. And so this sort of task is often called regression. We're going to be looking at this obviously from a high level view, not necessarily going into the math and everything in this, but this is obviously from a very high level view. What is the idea of regression? And you see this graph here that we have here. We have a y-axis and we have an x-axis. you see the y-axis has a value as its label, and you see the x-axis has a feature 1. And so the features, for instance, could be the predictors, right? They're the predictors. And so we could be giving the mileage of the car, for instance, could be a predictor. And associated with those particular predictors on your x-axis, we have a value. That value is the label, the price of the car. And so we have several features, let's say at the bottom. Well, let's make it a little bit more simpler. No, we'll stick with that. Price of the car, okay? Price of the car is the predictor. And based on that, we're going to have a value associated with that. And all these dots that you see here are the instances. And so you see the instances here along with the value, the price of the car. And so based on this particular regression model that we have here, we can introduce a new instance with certain characteristics called predictors, and then we can pinpoint a value that is associated with that. A value in this case, what's the value? Well, it'll be the label. What's the label? The price of the car. And so it'll determine the price of the car based on that. And you see each of these dots here, these are instances that we fed to the model, and based on that, we're getting values, which are basically the price of the car or the labels. So that is supervised learning there. Let's talk a little bit about now unsupervised learning. So what is unsupervised learning? Unsupervised learning is basically where the training set you feed to the algorithm does not include the desired solution. So basically there are no labels. There are predictors, but there are not labels. So the system tries to learn without a teacher. The teacher would be basically the labels, right? The labels plus the predictors. But in this case, we're only giving the predictors. So what are some examples of this? The book gives several examples. I picked about 4 of them. I think the book gave, 5 or so examples, but I picked 4 of them. The clustering algorithm is an example of this. The clustering algorithm, a good example of this is basically you have a group of people that are visiting a hotel, and you're giving characteristics of each of those people. So, for example, you could say, that one person, this one individual booked floor number 14, and he booked a 2-bedroom apartment. Another person booked floor number 14 and he picked a 2-bedroom apartment. Another person picked floor number 13 and picked a 1-bedroom room or something like that, right? And you give several examples of people, but you're not necessarily labeling any of the data. Okay, you're not labeling any of the data. And the clustering algorithm, it's given that group of visitors, and its job is to group these visitors into groups, into different groups. And so it'll group those people based off of predictors or characteristics that are similar to them. And so that's something that's very important. It's basically going to group them, for example, all the people who picked a 2-bedroom apartment. We're going to group all those people into one group. All the people who picked a 1-bedroom apartment, we'll group them into another group. We might group people based on what floor they chose in the hotel and different characteristics like that. But none of this information is labeled. All we're doing is giving it predictors, right? Predictors or features, I guess you could say as well. So that's what the clustering algorithm does. The clustering algorithm is an example of unsupervised learning. Another one is the visualization algorithm. The visualization algorithm is given a lot of complex and unlabeled data and outputs a 2D or 3D representation of that data with non-overlapping groups. So basically, you have a lot of data and you want to identify the characteristics that are common, and you're going to group them into sections that are non-overlapping with each other, right? And it's not labeled necessarily; it's unlabeled, but we want to group the predictors that are, characteristic of that are, the same within each of the groups, that are characteristic of each of the groups. Another one is the dimensionality reduction. This is very interesting because it makes your ML model run faster. And so it merges several correlated features into one. Its goal is to simplify the data without losing too much information. And so a good example in the book is, let's say we have a car's mileage. And so let's talk about something else. Rather than determining the price of a car, let's talk about the age of a car, how old a car is. We know that a car's mileage can be strongly associated with its age. Let's say we had to draw a graph, for instance, and the graph basically showed the mileage of cars and it showed how old the car was. We would expect most likely that as the mileage of a car went up, the age of a car, the number of years that the car has been driven or used, is going to increase at a proportional rate, right? That's something that we would obviously expect. Now, what we could do with that information, since we notice that correlation there, we can reduce that information of both age and mileage, which are now 2 characteristics, into one characteristic or one predictor. So rather than having two predictors, we could have one predictor. This is called feature extraction. This is called feature extraction because what we're going to do is let me read the formal definition here, the formal wording in the textbook. We'll merge them into one feature that represents the car's wear and tear. All right. That's called feature extraction. It helps the algorithm, it helps the machine learning algorithm run faster. And because we're eliminating the number of predictors, we're making them less. And so that would be useful, for example, even if we're trying to use supervised learning. Think about this, right? If you have the mileage and the age of the car, well, we just said that the mileage and the age are two characteristics that can be simplified into one using the idea of feature extraction, and that will make your machine learning algorithm for the supervised model run faster because we're eliminating down the number of predictors there. So that's dimensionality reduction. Let's talk about anomaly detection. Anomaly detection is another example of unsupervised learning. The system is given normal instances of an event occurring. When a new instance is introduced with different characteristics, it identifies it as an anomaly. And so here you see here we have basically a scatter plot of information with a trend line, I guess you could say, that you could draw. And you see that even though the information is unlabeled, the instances have a general flow to them. That being said, when we now have an anomaly somewhere outside of that data, it's identifying it as having different characteristics. It's an anomaly, it's unique in that particular instance. And so that's another example of unsupervised learning. So those are unsupervised and supervised learning. The next type of learning combines the two of them together and is actually the most commonly used one, which is semi-supervised learning. It's very difficult to get all your information to be labeled. That being said, you do want some labeled instances. And so semi-supervised learning takes advantage of both supervised and unsupervised learning by providing plenty of unlabeled instances and few labeled instances. And so basically, if you're trying to train your data, you obviously, for many of these big machine learning these big LLM companies like Gemini or OpenAI, they spend millions and millions of dollars on their training data. In fact, there have been studies to show that the power of data is a very powerful thing. There have been studies shown, and we'll get into this later on in the book, how the amount of data that you have is very, very important to determining how well a machine learning algorithm works. There was a study actually done, I believe, in 2009 or so, that showed that the amount of data that you have greatly influences the reliability, I guess you could say, or the accuracy of a machine learning algorithm, how good a machine learning algorithm is. And so the amount of data that you have is very important. And so because of that, it costs a lot of money to get a lot of data, which is why obviously many of these big companies spend a lot of money and they have that type of money to train their models so well. Not just so many people use them, but when they do train their models, they can't spend too much money, obviously, and so they often use semi-supervised learning, where you have few labeled instances but plenty of unlabeled instances. Unlabeled instances would obviously be much easier to get, maybe, than labeled instances. So it's partially labeled there. Let's give an example here. This example isn't totally accurate in the textbook, I guess you could say, because in this example, you have the triangles and the squares that are labeled and the circles are unlabeled. And so in this case, you technically have more labeled instances than unlabeled instances, but it's still demonstrating the idea that you're utilizing both of those characteristics. So in this example here, you notice here that we have triangles and squares. Those are the two labeled informations, right? And then you have these circles here, these gray dots. These are unlabeled data. And now we're introducing some arbitrary instance. You see here this arbitrary instance here. And we're asking the machine learning algorithm, based on the unlabeled data that you have here with the circles and the labeled data with the squares and the triangles, I want you to group one of these in one of these groups. And it will choose a group based on the unlabeled and labeled data. Okay, so that's an example there. A better example, I would say, would be Google. Sorry, let me get rid of that. Google Photos. So Google Photos. An example of this basically is, you. Let's say you upload all of your family photos into Google Photos. Google Photos can go through and identify people who are the same, right? In that instance, you're giving unlabeled data, right? You're just pouring in all your family photos. Well, obviously, certain people will appear in multiple photos, right? So you can see, for example, person A will be in photo 1, photo 5, photo 10, right? Person B is in photo 3, 4, and 6. And so what Google Photos can do is it can use unsupervised learning to group those people into particular groups. This is going back to the idea of clustering. Remember, we talked about clustering. The unsupervised part of the algorithm that's clustering. Clustering, remember, is given a group of visitors, group these visitors into groups. And so we can see the same idea here in um, in Google Photos here, because you're noticing here how you're uploading all your people and it's grouping the people who are the same, that they notice the same in each group. And so person A shows up in photo 1, 5, and 11. Person B shows up in photos 2, 5, and 7. This is the clustering part of the algorithm. Again, it's unsupervised because we haven't labeled the data yet. But now that the system basically has grouped has identified which people are the same in each different photo, that's the unsupervised part. Now it's going to ask you to label each of that data. So it's going to ask you to label who is person A, who is person B, who's person C. Give me a name for them. So person A can be Tom, person B can be Bob, right? And based on the labels that it can do, it can now just add a label to every single person. Notice in this particular instance, it used both unsupervised and supervised learning, because it used unsupervised learning in order to group these people up into different groups using the idea of clustering. But it also used supervised learning because it allowed you to add labels for each person and name each person in each photo. That was the idea of supervised learning. And so that's very useful as well. All right, and so that's semi-supervised learning. All right, let's talk a little bit about reinforcement learning. Reinforcement learning. All right, so reinforcement learning, I provided a picture here. Reinforcement learning basically is essentially a agent, which is a training system. An agent basically is allowed to make decisions and adapt based on the responses to those particular decisions. It's the decisions that it's making are within an environment, right? It's within an environment, and based on the decisions it makes, it's either going to get positive rewards or negative rewards. The positive rewards are referred to as rewards. The negative rewards are referred to as penalties. Based on a penalty or reward, the ML algorithm will determine what to do next. If it's a penalty, it'll say, okay, this is not a good choice to make. Let's choose a different choice. Let's choose a different choice based on the outcomes. If it's a positive outcome that comes into play, it'll say, okay, let's try to continue going down that same vein. And the path that it chooses, the rule that it has to determine which is better based on the rewards that it's given, is called a policy. Okay, so that's kind of what reinforcement learning is. And the thing that does this is called an agent. You may have heard of agentic systems, right? Maybe an agentic chat box or something like that. It's able to adapt with its environment. All right, and so you see here this example here with this picture. By the way, all these pictures that I'm taking are located in the book as well, so you can take a look at them in the book as well. But you see here that we have an agent here, and the agent sees, okay, we have fire and we have water. Which one is better? So it's going to observe that, and it's going to select an action using policy. Then it's going to perform that action. It's going to get a reward or a penalty. Here we see in this case, it's getting a negative reward. A negative reward is simply a penalty. And so since it touched that, it's saying fire equals bad. Next time, avoid it. It's going to update its policy, and then it's going to iterate until an optimal policy is found. Now, in this case, we only had two options, two choices. And so the obvious next choice would be to choose the water here. But let's say you have many choices. You would have to obviously go through all of them, or you could maybe employ a more efficient algorithm. But that's the idea of reinforcement learning there with an agent. All right. And so we run over reinforcement learning, semi-supervised learning. Reinforcement learning, you can kind of think of it as, you're getting a policy, but you have to update your policy later. That's the idea of reinforcement learning. And then unsupervised learning and supervised learning. Now, when it comes to reinforcement learning, I mentioned the word of agents. Agents, when it comes to actually programming, an agent is basically a tools plus an LLM, right? It's a tool plus an LLM. And so your tools might be, for example, some Python module, and you might be connecting to some LLM, some maybe Gemini API or an OpenAI. But that is what we are covering for today's lesson. And so if you like this video, make sure you hit the subscribe button down below and like the video, and I will see you in the next video.